Hey, it's me, Zephyr Beaverbrox, the British tech guru. Off camera, I took this transistor out and tested it, this one, and tested it, and it was fine. I don't think the resistors will have burned up, and I don't think the capacitor will be wrong. Anyway, I have this on the output here, and let's go for tools, and let's go for voltage. And what we're going to do, because I don't need the oscilloscope for this, what we're going to do is we're going to get 5.4 volts, 5.3, 5.4 volts with nothing connected to these two leads. Now, if I connect these two leads together, the voltage drops to 3.81 volts. That is excellent news, because that means that the transistor is having an effect. It's the opposite effect to the effect I thought it would have, because I thought the voltage would go up. But let us now try this Geiger counter this sensor. So what I'm going to do is I'm going to connect the sensor to the blue to the green and the yellow to the green and see what happens. And absolutely nothing. So now oh yes, and I've got my mildly radioactive junk there, so I'm going to put that there. Well, actually, I'm going to take it way away and see what happens. And we're getting 5.3 to 5.4 approximately. So I'm going to put this right beside the sensor, and we're going to reconnect, and .3 to 5.4. Okay, so what we're going to do, we're going to take this away again. I'm taking about 2 feet away, so it should be fine. And I'm going to try connecting the green to the green and the yellow to the blue. Reverse the polarity of the diode. I can't remember which way around it's wired. Anyway, I'm getting 3.8 volts, 3.8 dead. Now, put this right beside it. And it's going 3.801, 3.802. So move that away. And it still goes to about 3.807. Nothing really is changing. So I'm not quite sure what's going on there. So I'll disconnect that, and I'll disconnect the power. And this is the circuit that I downloaded, and it should work because it was in a prestigious journal. The only modification I've done to this circuit is that instead of having a wire detecting the, let's see, where are we? No, that's not it. Is that it? No, that's not it. Here we go. This is our wonderful paper, and as I just throw wires everywhere. Proceedings of the International Conference on Nuclear Technology. Okay. Now, somewhere here, I should have the circuit diagram that I'm trying to use. Or maybe not. Yeah. Wonder where that went. Yes. Okay. My lab is... is that it? Nope. So my lab... Oh, yes, that is it. Ha! Okay. So what they've got here is they've got a tin with one wire going down into the tin and the outside connected to the tin. They say this works. I don't know. They say it does. And I'm not really 100% sure what's going on, because I've replaced this with a Darlington transistor. So replaced this with a diode, with a light sensing diode, which should pick up the light from the cesium crystal. But it's not doing it, and this I'm not entirely sure quite why not. This circuit looks pretty reasonable. This diode, this capacitor here is to make sure that basically to collect the pulses so that it can be read with something as slow as an Arduino. This is a little bit of a mystery. The thing I was not expecting was the pulsing coming from the voltage converter, which is this thing. That I was not expecting. So that that puzzled me a little bit. I'm not sure quite what's going on. Maybe my little radiation source here is just not radioactive enough, and that is a little worrying, because it should, a decent Geiger counter should pick it up. And of course let me turn that off. The aim of this project is not just to build a Geiger counter, but to build something I can put on a drone or on some other device, or a balloon, something cheap that can be just launched, or a remote sensor that can be just placed somewhere and can communicate via LoRaWAN or something similar, or shortwave radio, giving radiation readings. Something that can just be placed in the environment. And that is, and I don't want to use a Geiger Muller tube because they're fragile. So this is an interesting problem, and if anybody has can see an obvious solution, I'd like to hear about it. I'm going to plug on with this project. Really not quite sure where I can go from here, because this is right. This resistor might be a little bit on the high side or a little bit on the low side. I'm not really sure. And that's a 10k resistor. That's a 10 megohm resistor, and the 10 megohm seems to be, well, looking at the circuit, it seems to be about right. The 10k resistor, I don't know, because I'm not using this, which will be which of course is going to be incredibly high resistance. So maybe this needs to be upped a bit, and 10k is just not enough. I don't know.